Hi, welcome back to this channel. Let's continue with the chapter Polymer objective questions. Question number 1. Polytetrafluoroethene is made from a monomer C. Which statement below is true about the C? Since we see this is the polyalkene, so means that the polyalkene, so the monomer basically will be the alkene. Monomer will be the alkene. And then we just return the bond back here. So the structure for the for the monomer will be CF2 double bond CF2. So it is a non-polar molecule. Yes, it is correct. B, undergo condensation is wrong. So basically, if we know it is polyalkene, the type of polymerization is addition. So second, C is bond angle is 90 degree, also not correct. Okay, so basically there is a three. If we look at each carbon here, when we draw the Lewis structure, each of the carbon here have 3 electron domain, 1, 2, and 3. So for the another carbon also 1, 2, and 3. So if 3 electron domain, the bond angle supposedly is 120 degree, 20 degree, not the Celsius. Okay, option D, it has geometrical isomer. So if we recall back the term, another term to represent geometrical is the cis-trans isomer. So if cis-trans isomer, they will be have two different group of atom. Okay, but here both are same, fluorine and fluorine. So that's why option D also not fulfill the requirement. So the only statement which is true about C is question number 1A. Question number 2. Which of the following monomer will going to have same empirical formula with the polymer? So basically this will refer to polyalkene. And where again the monomer supposedly will be the alkene. So among these four, so option C is the only alkene in this option here. So answer is C. Question number 3. Select the polyamide from the following polymer. So this is one of the example of the synthetic rubber. So from here we can see the monomer consists of carbon-carbon double bond. So basically if form the polymer, it will be as the polyalkene. While as we know for the proteins, the monomer of the protein is amino acid. So in the previous chapter, amino acid, we already know that both protein or both amino acid when combined, they will possible to form the peptide bond, which also is the amide functional group of amide. So this one is polyamide. So the answer is B. While for the PVC, if we look at here, this is the monomer for the PVC, which also consists of double bond. So this one also will form polyalkene. While for the tellurine, when we look at here, the functional group that we can obtain in the middle here is from the polymer here is the C double bond OO, which this is the polyester. So definitely the answer is B. Question 4. A monomer butadiene acid, and another one is the with a monomer T without the name given, but we can see there is amino group. So butadiene acid means that they will have COOH. So again, very obvious that we can see that there is carboxyl group, amino group come out in our mind. It will be has quite similar structure with the amino acid. So if amino acid, basically it can form the amide bond or the peptide linkage. So for then here, if it is peptide, so means that it is the C double bond O and H. So amino, not correct. Carboxyl also no. Carbonyl no. So the answer will be C, amide. Question number 5. Which of the following would be the monomer for condensation, polymerization? So there is two types of polymer. One is polyamide and then another one will be polyester. So if for the polyamide, it will be have the carboxyl group with the amino group. While for the polyester, we can have the carboxyl group with the hydroxyl group. So when we look at here, option A is carbon-carbon single bond. So option B is already consists of the ester, and option C consists of carbon-carbon double bond, while the option D we have the hydroxyl group. So among these four, obviously D is the one which near to the answer. Okay, question 6. Select a correct pair. So that means from here we know that there are two monomer to make up one polymer. So this polymer basically will be considered as copolymer because made up from two different monomer. Okay, so and then since we can see there is double bond here, so again we know that this polymer should be polyalkene. So if we want to get back the structure, so you just need to imagine that this bond will return to here, and then this bond will return to here, one electron from the bond, and then here one, and then here go back one, here one, and here another one. Okay, so from here we can see that CH2 will have double bond. Okay, and then we will have CH single bond because one bond will be break to form two electrons. So CH basically we will get the structure CH2 double bond CH, and then we bonded to CH3, and then here we will have another double bond which is the CH2. Okay, then now here we already stop at here. Another structure that we can see will be CHCl double bond and then CH2. So now let's check the structure. CH2 double bond CHCl. So here this one is matching with this, and then another one CH2 CH3. So here CH2 double bond CH. So basically this is the bond CH3 is okay, and then C double bond CH2. So this is the one. So the answer will be option A. Okay, question 7. Which of the compound can undergo self-polymerization? So as we know, generally we have polyalkene, we have polyamide, and also polyester. So basically, if polyalkene, supposedly we have carbon-carbon double bond. For amide, we'll have carboxyl group with the NH2, and polyester will be alcohol with the carboxyl group. So then now we try to check which of the following compound have this kind of the functional group. So question B, option B here, we can see there is two functional group, amino and also COOH. For option A, we only can see there is hydroxyl group, so cannot be formed, polyester. While for this one, we see that there is C double bond O, C double bond O, so also cannot form the, and also there is amide. Since there already is the amide, so also cannot form polyamide. While for the option D, we can see that there is amino group. So it is again very obvious, option B is the answer. Question number 8, nylon 66 has the repeating unit as below. So It is formed from the hexanediol acid and hexane 1,6-diamine. So when we have carboxylic acid with the amine, so basically the type of polymerization is condensation. And because of the amino group and also the carboxyl group, so we'll have the amide bond. So and then we know that from the carboxyl group, it will remove the OH, while the amino group, it will remove the hydrogen. So basically ammonia and H and OH combined, they will eliminate the water, not the ammonia. So the answer is 1 and 2 only. Question number 9. So the following diagram is the repeating unit for polyester. So and then we can double confirm with C double bond OO here. So if we want to get the monomer, so we will break down the bond over here, and then the left hand side here we can see C double bond O. So basically we know that polyester is from carboxylic acid with the alcohol. So definitely we will add on the OH at both C double bond O. So this one will be the answer. And then another one will be the alcohol. So CH2, CH2OH. So option 1 also correct. So this is the answer for the repeating unit of polyester. Last question in this chapter, what is the correct statement for polyethylene? So from here we can see ethene, so we know this is a polyalkene. So if alkene, they will able to decolorize the bromine, so it's correct. So from the name polyethylene, so means that the monomer is ethene with the formula CH2CH2, and we can simplify as well the empirical formula to CH2. Has a sp3 carbon, means that they will have single bond. But as we know, polyalkene consists of carbon-carbon double bond. So option 3 is wrong. So the correct answer is option 1 and 2 only. Okay, so we already end of the video. So we already discussed all the tutorial questions, and you are going to sit for your PSPM. So all the best for your PSPM, and see you again. Bye bye.